Somewhere in the South Pacific, beneath about 40 meters of water, resting on a coral reef that no map had ever named, there are the remains of two French frigates, a bronze cannon, an anchor chain, fragments of timber that the ocean has been slowly dissolving for more than 200 years. The ships belong to one of the most decorated navigators of the 18th century. He had survived wars, crossed the Atlantic, mapped coastlines from Alaska to Australia. He left his last port in January of 1788, sent a single letter home, and was never seen again. No distress signal, no survivors, no explanation that history has ever been able to fully satisfy. He was not the first. He was not the last. And the ocean that took him has been taking ships and the people inside them. For as long as human beings have been asking the question that has driven more voyages, more courage, and more catastrophic miscalculation than any other question in the history of the world, where does the ocean end? This is the story of the people who went looking for the answer. There is a particular kind of silence that only the ocean can produce. Not the silence of an empty room, or the silence of a library late at night, but something older and wider. A silence that has depth to it, the way a hole has depth, the way an unanswered question has depth. It is the silence that fills the space where a ship used to be, the absence that remains when a vessel and every soul aboard simply vanishes into the blue immensity and is never seen or heard from again. That silence has haunted humanity for as long as we have been going down to the sea in ships. And the history of ocean exploration is, in no small part, a history of that silence, of the people who sailed toward it anyway, who leaned into the unknown with nothing but rope and timber and wind and courage, and who sometimes did not return. The year was 1788, and the world was a different kind of place. Napoleon had not yet risen. The French Revolution was still a year away from its first tremors. The Pacific Ocean had only recently begun to reveal its true dimensions to European navigators, and even the most learned men in Paris and London still held cartographic secrets they could not name. Into this world sailed Jean-François de Gallo, the Comte de la Pérouse, a French naval captain of considerable reputation, a man who had fought the British in the American Revolutionary War and distinguished himself at the Battle of Hudson Bay. He was, by any measure of his era, an accomplished and careful man of the sea, and in the summer of 1788, he sailed his two frigates, the Boussole and the Astrolabe, into the waters of the South Pacific, sent a brief dispatch from Botany Bay in Australia, and was never seen again. All of it gone, swallowed into the blue silence, as if it had never existed at all. Rescue missions were sent. Rumors circulated. For years, people believed the ships might be found. And then decades passed, and still nothing. And the story of La Pérouse began to settle into the long history of things that the ocean simply refused to return. It would be another 40 years before pieces of wreckage washed up on the reef at Vanikoro, in what is now the Solomon Islands. Fragments of timber, a bronze cannon, an anchor, just enough to suggest what had happened. Too little to explain how or why. The mystery, in its essential character, was never truly solved. 2 ships, 220 men, and whatever knowledge they had gathered, all of it surrendered to the sea. This is where our story begins. Not with a triumph, not with the moment a great navigator planted a flag on some newly discovered coast and declared victory for his king, but with a disappearance. Because the disappearance of La Pérouse like so many disappearances before and after it, contains within itself the central obsession of every sailor who has ever pointed a bow toward the open water and pushed away from shore. What is out there? Where does the ocean end? Is there an edge? And if there is, what happens to the ships that find it? These are not merely the questions of a pre-scientific age, though for most of human history, they were asked with the kind of urgent literalness that we no longer apply to them. For thousands of years, across dozens of civilizations, the ocean was understood to have an edge, a physical terminus, a place where the water fell away or froze or turned to some impenetrable substance that ships could not cross. The edge was real. It was drawn on maps. Sailors talked about it the way we might talk about a known danger, a sharp curve on a familiar road, a cliff that everyone agrees you should not approach too closely. And yet, generation after generation, there were always sailors who approached it anyway, who pushed a little further, who raised their sails and pointed their prows toward the horizon and said, quietly or boldly, "Let us see what is there." Some of them came back with answers that changed the world. Some of them came back with only questions. And some of them, like the men aboard the Boussole and the Astrolabe, simply did not come back at all. The ocean has a way of keeping its secrets. It holds them down in its darkest trenches, buries them under centuries of sediment, scatters them across reefs that no map has ever named. But the secrets are still there, pressing upward through the fathoms, surfacing sometimes as a fragment of timber, a bronze cannon, a set of bones on a distant shore, and the story of how humanity came to understand the ocean, to map its currents, measure its depths, cross its silences, and confront the particular madness that the open sea can induce in even the most disciplined human mind. That story is one of the longest and most extraordinary adventures in all of human experience. It begins, as the oldest things often do, in a world that looks nothing like our own, where the ocean was not a body of water to be navigated, but a boundary to be respected, a frontier where the known world ended, and something else, something vast and formless, and perhaps divine, began. Long before anyone had ever drawn a coastline on a piece of parchment, long before anyone had invented the compass or the sextant or the concept of longitude, human beings understood, with a kind of deep instinctive certainty, that the world had edges. The land you could walk on eventually ended. The sea that bordered the land eventually ended too. And beyond that ending, there was something else. Something that different cultures name differently, but that all cultures, in one form or another, recognized as belonging to a category of experience that was not meant for living human beings. The ancient Greeks called it Oceanus, not the ocean as we understand it, a collection of connected saltwater bodies with names and depths and temperatures, but a single vast river circling the whole of the flat disk of the world like a moat surrounding a castle. Oceanus was more than geography. He was a deity, one of the Titans, older than Zeus himself, and the waters that bore his name were understood to be both physical and metaphysical, a boundary between the world of the living and the world of the dead. To sail on the ocean was, in a sense, to approach the underworld, to sail across it, to attempt to reach the other side, was an act that exceeded what mortals were supposed to attempt. The heroes of Greek mythology, who ventured to the edge of the world, Odysseus, Heracles, were not ordinary sailors. They were individuals of exceptional, superhuman capability, and even they required divine assistance to navigate the waters at the world's rim. The Romans inherited much of this geography, both physical and mythological, and added their own contributions to the mythology of the ocean's edge. The phrase, the Romans used for the Atlantic, Mare Tenebrosum, translates roughly as the Sea of Darkness, and it captures something essential about how a landlocked Mediterranean civilization understood the vast grey waters that lay beyond the Pillars of Hercules, the rocky promontories flanking the Strait of Gibraltar. The Mediterranean was the centre of the world. The Atlantic was its negation, uncharted, uncalm, unknowable. The historian Livy wrote that the Atlantic churned constantly with monstrous waves. The philosopher Strabo described it as a boundless sea from which no vessel returned. These were not the observations of people who had actually crossed it. They were the amplified fears of people who had stood at its edge and looked out into the grey distance and felt, with every nerve in their bodies, that this was a place where humans were not welcome. The Babylonians, centuries before the Greeks, had constructed a world map that is among the oldest surviving cartographic documents in history. Inscribed on a clay tablet, now housed in the British Museum, this map depicts the known world as a disk surrounded by a ring of ocean, labelled the Bitter River. Beyond the Bitter River are regions described in the cuneiform annotations as places of chaos, inhabited by strange creatures and strange conditions, eternal darkness, extreme cold, a place where the sun does not shine. The map does not show what happens if you cross the Bitter River. It does not need to. The implication is clear enough. Beyond the ocean, the world as it can be understood simply stops. What is remarkable about all of these different cosmological systems is not that they believed the world was flat. Many ancient cultures had more sophisticated views of the Earth's geometry than this simple characterization suggests, but that they all agreed on one essential point. The ocean was a boundary, and the far side of that boundary was not a place for human navigation. This was not simple ignorance. Many of the cultures that constructed these worldviews were sophisticated astronomers, mathematicians, traders, engineers. They understood a great deal about the physical world. Their understanding of the ocean as a limit was not based on an absence of intelligence. It was based on something else, on a combination of genuine ignorance about what lay beyond the visible horizon, and a deep cultural encoding of the ocean as a category of sacred danger. The taboo against ocean sailing was, in many cultures, extraordinarily powerful. The ancient Chinese texts describe the Eastern Ocean as the place where the sun sets into the water and is consumed by a great abyss. Chinese navigational culture, despite producing some of the most sophisticated ships in the ancient world, remained largely coastal for centuries. Not because Chinese shipbuilders lacked the skills to construct deep-water vessels, but because the open ocean was understood to be spiritually, as well as physically, dangerous. The spirits of the deep waters were not friendly spirits. They were the spirits of the uncharted, the untamed, the beyond. In the cultures of the ancient Near East, the ocean played a similar role in the foundational mythology of creation itself. In the Babylonian creation epic, the Enuma Elish, the world is formed from the body of the sea goddess Tiamat, who is slain by the god Marduk. The ocean, in this cosmology, is not merely a body of water. It is the primordial substance from which existence itself is made, and the churning of the sea reflects the ongoing tension between order and the chaos that preceded it. To sail on the ocean was, in a very literal mythological sense, to sail on the body of chaos itself. To push beyond the known waters was to invite that chaos into your life, your ship, your crew. And yet, humans pushed. They always push. It is perhaps the most consistent feature of our species. This inability to respect a boundary simply because everyone agrees it should not be crossed. Somewhere, in every age, in every culture, there have been individuals who looked at the horizon, that false, receding boundary that always promises more beyond itself, and decided that the promise was worth more than the warning. The Phoenicians were among the first great civilizations to make that decision on a systematic, commercial scale, and in doing so, they helped redefine what the ocean was and what it was capable of yielding to those with the courage to sail it. The city of Carthage, at its height in the 5th century before the Common Era, was the wealthiest and most powerful city in the Western Mediterranean world. Its harbour could accommodate more than 200 warships. Its merchant fleet ranged across trade routes that stretched from the tin mines of Cornwall in distant Britain to the gold-bearing rivers of West Africa, a distance of more than 4,000 miles as the crow flies, and considerably more as the ship sails, given the winds and currents of the Atlantic coast. Carthage was a Phoenician colony, established by settlers from the great Phoenician port of Tyre, on the coast of what is now Lebanon. And the Phoenicians, in their homeland and their colonies, were the most accomplished maritime traders of the ancient world. The word Phoenician comes from the Greek pheniki, meaning purple, a reference to the extraordinarily valuable dye that the Phoenicians extracted from the murex sea snail and traded across the Mediterranean at prices that rivaled gold. But purple dye, however valuable, was only the beginning of what the Phoenicians bought and sold. They traded in cedar wood from Lebanon, in glass from their workshops at Sidon, in copper from Cyprus, in silver from Spain, in slaves, in grain, in spices, in the raw metals and finished goods that flowed along the connective tissue of ancient Mediterranean commerce. They were, in the truest sense of the word, the merchants of the ancient world, and the ocean was their highway. What distinguished the Phoenicians from other ancient seafaring cultures was not just their willingness to sail, but the distances they were willing to sail in the service of trade. The Greeks, for all their celebrated seafaring traditions, tended to sail along the coasts, keeping land in sight whenever possible, moving from island to island across the relatively calm and sheltered waters of the Aegean. The Phoenicians, by contrast, were willing to sail at night, which required navigating by the stars, and willing to sail into open ocean, out of sight of land, for days at a time. They were the first Mediterranean civilization to use the North Star, which they identified with such precision that the Greeks called the constellation of the Little Bear Phoeniki in their honor. The North Star was a Phoenician discovery, in the practical sense of that word, a navigational anchor that made night sailing across open water not only possible, but reliable. With this tool, and with the accumulated knowledge of Atlantic currents and winds that generations of coastal trading had given them, the Phoenicians extended their routes south along the Atlantic coast of Africa, past the sandy shores of Morocco and Mauritania, into the hot, humid, storm-prone waters of the West African coast, waters that no Mediterranean civilization had previously penetrated with any consistency. What they found there, and what they traded, was remarkable. Gold dust, ivory, exotic animals, and new varieties of spice that opened entirely new markets back in the Mediterranean. It was from Carthage, in approximately 470 BCE, that one of the most audacious voyages in ancient history departed. Its commander was a navigator named Hanno, a suffet, or magistrate, of Carthage, a man of sufficient standing in his city to command 60 ships, and, according to the surviving account of his voyage, 30,000 men and women. These numbers are almost certainly exaggerated. 60 ships crewed by 30,000 people would have required each vessel to carry 500 passengers, which is impossible for the kind of ships the Carthaginians built. But the voyage itself is real, attested not only by the account preserved in Greek translation, but by a number of geographical details that correspond closely to actual features of the West African coast as we know it today. Hanno sailed south from Carthage, through the Pillars of Hercules, and down the Atlantic coast of Africa, establishing trading colonies as he went. He reached the Senegal River, which he called the West Horn. He sailed further, past what may have been the Gambia River, and into equatorial waters that would have been hotter and more humid than anything any Mediterranean navigator had experienced before. He described an island filled with strange creatures, interpreted by some scholars as the chimpanzees of the Guinea coast. He described a great mountain of fire, which modern researchers believe was Mount Cameroon, a still active volcano on the Gulf of Guinea, whose eruptions are accompanied by extraordinary displays of smoke and glowing lava visible from the sea. And then, at some point past this mountain, Hanno turned around. He ran short of provisions. He sailed home. The account of Hanno's voyage, known as the Periplus of Hanno, is one of the most debated documents in ancient history. Scholars have argued for centuries about exactly how far he went. Some believe he rounded the Bight of Benin and penetrated as far as the Cameroon coast. A more ambitious minority of researchers have suggested he may have reached the Gulf of Guinea, perhaps even the equator. Whatever the precise extent of his journey, what is certain is that Hanno sailed further down the coast of Africa than any known Mediterranean navigator before him, and that he did so not in the service of scientific curiosity, but in the service of commerce, looking, as Phoenician navigators always looked, for the next market, the next resource, the next source of value that could be extracted from the world's edges and brought home for profit. But there is another Phoenician voyage, even more extraordinary, even more debated, and considerably older than Hanno's expedition. The Greek historian Herodotus, writing in the 5th century BCE, describes what he himself finds almost unbelievable: a Phoenician circumnavigation of Africa, commissioned by the Egyptian pharaoh Necho II, sometime around 600 BCE. According to Herodotus, a fleet of Phoenician ships departed from the Red Sea, sailed south and then west along the African coast, rounded the southern tip of the continent, a cape they could not have named, since it would not be named Cape of Good Hope until Bartolomeo Diaz rounded it 2,000 years later, and returned through the Mediterranean to Egypt. The journey took 3 years. Along the way, the sailors made landfall twice a year to plant and harvest grain, using the African coast itself as a provisioning station for a journey so long that they could not carry enough food to sustain it otherwise. Herodotus, characteristically, tells us the detail that convinces him the story might be true at the same time that it strikes him as most unlikely. The sailors, he reports, claimed that as they sailed around the southern tip of Africa, the sun was on their right, that is, to their north. This is, of course, exactly what would happen if you were sailing west around the Cape of Good Hope in the southern hemisphere, where the sun appears in the northern sky. Herodotus did not understand why this would be the case, and so he notes it as something he finds unbelievable. To us, it is the detail that suggests the story might actually be true. Whether the circumnavigation of Africa happened, and the question remains genuinely open among ancient historians, the fact that it was possible to attempt it at all reflects something crucial about what the Phoenicians understood about the ocean. They understood, on a practical level, that the ocean was continuous, that coasts connected to coasts, that if you kept a landmass on your left and kept sailing, you would eventually come back to where you started. They understood, in other words, that the ocean did not have an edge, not a real one, not one that would swallow your ships. What they did not know, could not know without instruments and mathematics, was how large the ocean truly was. The circumnavigation of Africa was possible because the southern tip of the continent is relatively close to the Atlantic side. The true immensity of the ocean, in its Pacific form, was something that would not be confronted until more than 2,000 years later. And when it was confronted, when European navigators first began to understand the sheer, staggering, mind-defeating size of the Pacific, the effect on those who crossed it was as profound and as disorienting as anything the ocean had ever produced. But before that confrontation, there was a Greek merchant from Massalia, a man whose contemporaries thought him a liar, whose book was dismissed as fantasy, and whose observations were so accurate that it would take modern oceanographers and historians 2,000 years to vindicate him. In the summer of some year between 325 and 320 BCE, historians cannot pin it more precisely than that, a merchant and astronomer from the Greek colony of Massalia, on the southern coast of what is now France, slipped past the Carthaginian naval blockade of the Strait of Gibraltar, sailed north into the Atlantic, and vanished from the world of Mediterranean geography for a period of months or possibly years. When he returned, he brought back an account of places so strange and so far beyond the known world that most of his contemporaries simply refused to believe him. His name was Pytheas. He was not a great naval commander, not an aristocrat, not a religious pilgrim. He was, in the most straightforward sense of the word, a merchant, a man who made his living by understanding geography in the way that commercial people understand it, not as an abstraction, but as a collection of real distances, real winds, real tides, and real commodities to be bought and sold. He sailed north, past the coasts of Gaul, across the water that separated the continent from the large island he called Britannicae, Britain. He went ashore there. He measured the latitude using a gnomon, a vertical stick whose shadow can be used to calculate the angle of the sun, and thus one's position on the Earth's surface. He found, to his professionally gratifying satisfaction, that the latitude he calculated corresponded to a position significantly further north than any Greek had previously measured. And then he sailed further north still. He passed the northern tip of Britain and entered waters that no Greek navigator had ever described. He was sailing into the North Atlantic now, into the deep grey waters between Britain and what he called Thule, an island 6 days' sail north of Britain, which modern scholars variously identify as Iceland, Norway, or possibly the Faroe Islands. The debate about exactly where Thule was has occupied historians for centuries, and remains genuinely unresolved, which is perhaps fitting for a place that has always served as a symbol, less of a specific location than of the very concept of the uttermost north. What Pytheas described when he reached the vicinity of Thule was something that no Mediterranean Greek had ever encountered, and something that his readers back in Massalia and Athens and Alexandria would have found genuinely difficult to visualize. He described a sea that could not be sailed through, not because of storms or monsters, but because of a strange substance that filled the water, something neither solid nor liquid, something that suspended the ships and prevented them from moving. He called this substance sea lung, which is translated as sea lung in most versions, and he described it as a mixture of ice, sea, and air, a kind of thickened, jelly-like medium that transformed the ocean around Thule into something more like a bog than a sea. For centuries, this description was taken as evidence that Pytheas was a fantasist and a fraud. Strabo, the influential Roman-era geographer, dismissed him contemptuously. Polybius, another ancient historian, called him a man who had lied about everything he claimed to have seen. The image of the sea lung, this gelatinous, impenetrable ocean at the top of the world, seemed simply too strange to be credible. It was the kind of detail that belonged in mythology, not in a merchant's navigational report. And yet, in the 20th century, oceanographers studying the waters around Greenland and the Norwegian Sea began paying closer attention to a phenomenon known as grease ice, the early stage of sea ice formation, in which microscopic ice crystals form throughout the water column and give the ocean a viscous, gelatinous consistency. Grease ice is, in effect, a sea that cannot be sailed through. It looks, to anyone who sees it for the first time, exactly like a body of water that has been transformed into something between ice and sea. It is, in Pytheas's language, a sea lung, and it occurs, naturally and predictably, in precisely the waters north of Britain, where Pytheas would have been sailing. The conclusion is almost inescapable. Pytheas actually went there. He actually saw it. His account, dismissed as fantasy for 2 millennia, was an accurate description of a real oceanographic phenomenon. What Pytheas gave the world, in his account of his voyage, a book called On the Ocean, which survives only in fragments quoted by later ancient writers, who were mostly using him as an example of unreliability, was something more valuable than a trade route or a new colony. He gave the world evidence that the ocean beyond the known Mediterranean world was real, navigable, and full of phenomena that the learned men of the South had never imagined. He described tides, the rise and fall of the sea level that was simply not a notable feature of the tidally minimal Mediterranean, but which became dramatic and significant as you moved north into the Atlantic. He described the midnight sun, the phenomenon at high latitudes where the sun barely dips below the horizon in summer, producing nights that are not really night at all. He described the aurora borealis, perhaps, in his account of the lights that appeared in the northern sky. He also confirmed, by direct measurement with his gnomon, that the earth was spherical, not flat, and that the curvature of that sphere could be calculated by careful astronomical observation. He was working, in other words, not as a mythographer, but as a scientist, applying the tools of Greek mathematics to the real landscape of the Northern Ocean and arriving at conclusions that were, by and large, correct. The edge of the ocean was not a falls into the void. It was a frozen sea, and the frozen sea could be reached. And it was the most extraordinary thing he had ever seen. When Pytheas returned to Massalia and wrote his account, he set in motion a chain of intellectual consequences that would unfold over the next 2,000 years. He demonstrated that the Atlantic Ocean was real, vast, and navigable. He demonstrated that there were human beings living at latitudes far beyond what Mediterranean civilization had previously known. He demonstrated that the natural world beyond the edge of the known maps was not the realm of chaos and monsters, but a place that obeyed the same physical laws as the Mediterranean, even if those laws produced phenomena, grease ice, midnight sun, tidal bores, that looked, to the Mediterranean trained eye, like magic. And yet, Pytheas was not believed. He was not honored in his time. His book was copied and transmitted across the ancient world primarily as an object lesson in credulity, a collection of travelers' tales so obviously exaggerated that no serious geographer should treat them as reliable. This pattern, the accurate report dismissed as fantasy, the careful observer called a liar, the new geography rejected in favor of the comfortable old one, would repeat itself many times in the centuries to come. The ocean had a way of making even the truthful sound like liars, because the truth of the ocean was so much stranger than the stories people preferred to believe. 600 years after Pytheas sailed north, another great tradition of ocean navigation was developing, in a part of the world that European scholars would not take seriously for a very long time. In the ports of Arabia and along the coasts of the Indian Ocean, navigators had built a system of maritime knowledge so sophisticated, so precise, and so thoroughly integrated into the astronomy and meteorology of the region that it made the cautious coastal sailing of the Mediterranean look almost primitive by comparison. There is a wind that comes. Every year, with the reliable regularity of a clock, it comes from the southwest in summer, beginning around June, gathering strength through July, and filling the sails of every ship in the Indian Ocean with a force that can drive a loaded dhow from Aden to Calicut in 3 weeks or less. And then, in November, the wind reverses. It blows from the northeast with equal certainty, and the ships that went east in the summer go west in the winter, carried home by the same atmosphere that carried them out. This is the monsoon, from the Arabic mawsim, meaning season, and its discovery, or rather its systematic exploitation, was perhaps the single most important piece of oceanographic knowledge in all of pre-modern history. The monsoon had been known, in a practical sense, to Indian and Arab sailors for centuries before anyone wrote it down in a way that has survived. The evidence for early Indian Ocean trade is preserved in archaeology, in the Roman coins found at Indian sites, in the Indian textiles found in Egyptian tombs, in the Chinese porcelain recovered from shipwrecks off the coast of East Africa. By the 1st century of the Common Era, a Greek-speaking Egyptian merchant had written a detailed commercial guide to the Indian Ocean ports, called the Periplus of the Erythraean Sea. Erythraean meaning red, referring to what we now call the Red Sea, but used loosely to encompass the entire northwestern Indian Ocean. This text describes, with remarkable precision, the seasonal winds, the port cities, the goods traded at each stop, and the sailing times between them. It is, in essence, a captain's handbook for the monsoon routes, written by someone who had sailed those routes himself and understood them from the inside. But the man whose name has come down to history as the master of the Indian Ocean, the navigator who synthesized centuries of accumulated knowledge about monsoons, currents, stars, and seasonal patterns into a written tradition that influenced sailors across the ocean world was Ahmad ibn Majid, who was born sometime around 1432 on the coast of Oman and died sometime after 1500. The precise dates obscured by the same historical fog that obscures so many lives from the pre-modern era. Ibn Majid's reputation preceded him across the Indian Ocean. He was known as the Lion of the Sea, and the title was not honorific in the way that such titles sometimes are. It described something real about his relationship to the ocean, which was that of a man who had spent his entire life on the water, who had sailed every route of consequence in the Indian Ocean world, who had studied the stars with the rigor of an astronomer, and the practicality of a man whose life depended on reading them correctly. He wrote poetry about navigation, actual poetry, composed in Arabic, which described in elegant verse the positions of the stars, the behavior of the currents, and the seasonal patterns of the winds. Navigation, for Ibn Majid, was not merely a technical skill. It was an art form, a discipline of observation and memory and experience that deserved to be expressed in the most refined literary form available. His greatest work was a text called the Kitab al-Fawaid fi Usul, Ilm al-Bahr wal-Kawaid, usually translated as the Book of Useful Information on the Principles and Rules of Navigation. Written around 1490, it is one of the most comprehensive navigational manuals ever produced in any tradition, covering not only the Indian Ocean, but also the Red Sea, the Persian Gulf, and portions of the East African and Southeast Asian coast. The book describes the positions of more than 100 stars and their usefulness for navigation. It describes the characteristics of the monsoon at different times of year and at different locations. It describes the hazards of specific routes, the reefs, the shoals, the dangerous headlands, with the specificity of a man who has personally encountered them. What makes Ibn Majid's contribution particularly remarkable is what it tells us about the navigational culture of the Indian Ocean world in general. While European sailors were still creeping down the coast of West Africa, terrified of what might lie beyond Cape Bojador, a fear we will return to, Arab navigators were routinely crossing deep water routes of 1,000 miles and more, timing their passages to the monsoon, reading the stars with instruments of extraordinary precision, and maintaining a commercial network that connected the markets of China, India, Persia, Arabia, and East Africa into a single interconnected trading world. The Indian Ocean was, in this period, the most heavily trafficked ocean in the world. Its navigators were not pushing into the unknown. They had already pushed into the unknown centuries earlier and had come back and mapped what they found and built an entire civilization on the profits. The story of Ibn Majid carries a strange footnote, one that has been debated by historians for centuries, with an intensity that suggests it touches on something more than mere historical curiosity. In 1498, the Portuguese navigator Vasco da Gama, having successfully rounded the Cape of Good Hope and entered the Indian Ocean for the first time, arrived at the port of Malindi on the East African coast. He needed a pilot, someone who knew the route across the Indian Ocean to the coast of India. And according to some accounts, some versions of the story that circulate, with the persistence of things that may or may not be true, the pilot who agreed to guide da Gama across the ocean to Calicut was Ahmad ibn Majid himself. If this is true, then the man who knew more about the Indian Ocean than any other person alive unwittingly handed the keys of that ocean to a European naval power that would, within decades, use its military superiority to seize the spice trade and begin dismantling the Arab commercial network that Ibn Majid had spent his life serving. Ibn Majid is reported, in some accounts, to have spent his later years in bitter regret over what he had done, to have written poetry lamenting his role in the transformation that followed. Whether these accounts are accurate is difficult to determine. The historical record is unclear enough to permit doubt. But the image endures. The greatest navigator of the Indian Ocean, guiding his ocean's conqueror across the water he loved. The Indian Ocean world that Ibn Majid knew was an ocean of established roots and accumulated knowledge, an ocean that had been understood and exploited for centuries. It was not an ocean of edges and terrors. But on the other side of the world, in the enormous blue emptiness of the Pacific, there was an ocean whose vastness genuinely dwarfed any human scale of reference. An ocean that was so large that crossing it should have been, by any reasonable calculation, impossible. And yet it had been crossed, centuries before the first European ship ever entered it, by people in small double-hulled canoes, navigating by stars and waves and birds, who not only crossed it, but settled every habitable island from Hawaii to New Zealand to Easter Island, creating one of the greatest maritime civilizations the world has ever produced. There is an archipelago in the center of the Pacific Ocean called Hawaii. Its nearest continental neighbor is the coast of California, approximately 2,400 miles to the east. Its nearest southern neighbor in the Pacific island world is the Marquesas, approximately 2,100 miles to the southeast. Between Hawaii and the Marquesas, and between the Marquesas and every other island group in the vast Pacific Triangle that runs from Hawaii in the north to New Zealand in the southwest to Easter Island in the southeast, there is nothing but water. Open, deep, unrelenting water, with winds and currents that can assist you or oppose you with equal indifference, and a sky full of stars that are perfectly happy to guide you if you know how to read them. The people who settled Hawaii, the Marquesas, New Zealand, Tahiti, Easter Island, Tonga, and hundreds of other Pacific islands, the people collectively and somewhat imprecisely known as Polynesians, accomplished in their canoes something that European navigators would not manage in their largest ships for another 1,000 years. They crossed the Pacific, deliberately, repeatedly, in both directions. They navigated not by accident but by design, using a navigational system so sophisticated that it took Western oceanographers and anthropologists most of the 20th century to fully understand and document it. The question of when the Polynesian settlement of the Pacific began is one that archaeologists have been refining for decades. The current consensus places the earliest expansion of the culture that would become Polynesian in the Western Pacific, near Vanuatu and Tonga, around 1000 BCE. The settlement of Eastern Polynesia, the most distant and most isolated islands, appears to have occurred in waves between roughly 700 and 1200 CE. The Hawaiian Islands were settled around 300 to 500 CE. New Zealand, the last great landmass to be inhabited by humans, was settled by Polynesian voyagers around 1250 to 1300 CE. Easter Island, Rapa Nui, was settled around 800 to 1200 CE, a date range that encompasses the very edge of what ocean navigation can reasonably accomplish. Easter Island is 1,300 miles from the nearest inhabited island, Pitcairn, and more than 2,000 miles from the South American mainland, To reach it, to find a tiny speck of volcanic rock in the middle of the world's largest ocean, required navigational skill of the highest possible order. The Polynesian navigational system has no single name, because it is not a single technique, but a web of interlocking methods that work together to create a comprehensive picture of position and direction. The stars, most obviously, are part of this system. Polynesian navigators memorized the rising and setting points of hundreds of stars, creating a mental map of the sky that functioned as a compass rose with dozens of bearing points rather than 4. But the stars are only visible at night, and only when the sky is clear, and the Pacific can produce overcast conditions that last for days. So Polynesian navigators also read the swell patterns, the long, low waves generated by distant weather systems that travel across the Pacific with remarkable consistency and can be felt through the hull of a canoe, even when they cannot be seen. Different swells come from different directions, and an experienced navigator could feel the angle of the swell against the hull and use it to maintain a course, even on a cloudy, starless night. They read the behavior of birds. Certain species, the golden plover, the frigate bird, the noddy tern, have predictable patterns of movement in relation to islands. They fly toward land in the evening. They appear in certain zones around islands and not others. They serve, in effect, as biological navigation aids. They read the color of the water, which changes in the vicinity of islands as fresh water from rainfall and rivers mixes with the salt water and alters its hue. They read the clouds, which tend to form over islands and maintain distinctive shapes above their summits, even when the island itself is below the horizon. Perhaps most remarkably, they read the stars through their bodies. The navigator sat in the bow of the canoe, not watching the horizon, but feeling the motion of the hull, sensing the subtle directional information encoded in the way the swell interacted with the boat, interpreting this information against the mental map of stars and swells and currents that they had spent years building through training and experience. This was not mystical knowledge, though it was sometimes described in spiritual terms. It was physical knowledge, the kind of knowledge that lives in the muscles and the inner ear, and the accumulated pattern recognition of a lifetime spent on the water. The man whose modern reputation has become most closely associated with the revival of traditional Polynesian navigation is Mau Piailug, a navigator from the Carolinian island of Satawal, who carried the tradition of non-instrument navigation into the 20th century, at a time when it had all but died out across the rest of Polynesia. In 1976, Piailug served as the traditional navigator aboard the Hokulea, a reconstructed Hawaiian double-hulled voyaging canoe, on a voyage from Hawaii to Tahiti, conducted without modern instruments of any kind. The voyage took 33 days, and when the Hokulea arrived at Tahiti, it arrived within 5 miles of the intended landfall. It was one of the most celebrated moments in the history of Pacific navigation, and it demonstrated, in a way that no academic argument could match, that the ancient voyages of the Polynesian expansion were not accidents of wind and current, but deliberate, skilled, precisely executed navigational achievements. What the Polynesians understood about the ocean as a living system of patterns and signs, readable by those who had learned to read it, was fundamentally different from the way the Europeans who would later enter the Pacific understood it. The Europeans brought instruments, compasses, sextants, chronometers. The Polynesians brought themselves, their bodies, their memories, their senses, their knowledge of how the living world of wind and wave and bird and star articulated the geography beneath it. Neither approach was superior in all circumstances. The instruments worked better in conditions where traditional knowledge was unavailable. The traditional knowledge worked better and was often more precise in the hands of someone who had truly mastered it. The Pacific, for the Polynesian navigators, was not an emptiness to be crossed. It was a landscape, a liquid landscape, constantly changing in its surface, but consistent in its deep patterns. And they moved through it with the confidence of people walking through a familiar countryside, reading the signs that told them where they were and where they needed to go. The ocean had no edge for them. It had destinations and the skill to reach them, half a world away, at roughly the same time as the later phases of the Polynesian expansion. A very different kind of ocean people was pushing into a very different kind of unknown. In the grey, cold, storm-tormented waters of the North Atlantic, Norse sailors in open longboats were beginning to probe the edge of the world that their mythology told them lay just beyond the horizon. Iceland rises from the North Atlantic like the exposed edge of a submerged mountain range, which is, in geological terms, precisely what it is, a volcanic mass sitting on the mid-Atlantic ridge, surrounded by some of the coldest, roughest, most unpredictable ocean in the Northern Hemisphere. The weather around Iceland changes with a speed that experienced sailors still find unnerving. A clear sky can become a whiteout blizzard in the time it takes to eat a meal. The waters off the southern coast can produce waves of extraordinary size in very short periods, driven by the deep water swells of the open Atlantic, meeting the shallow continental shelf. Iceland is not a forgiving landfall, and yet, by roughly 870 CE, Norse settlers had established permanent communities there, navigating from Norway across more than 600 miles of open Atlantic in vessels that had no keel, no cabin, and no reliable means of determining longitude. The Norse longship is one of the most remarkable pieces of naval engineering in history, though its admirers have sometimes celebrated it in terms that obscure what it actually was. An open boat. The great Viking longships, the Draka, the Snekja, the Nar, were open-decked vessels with a single mast carrying a square sail and ranks of oarsmen to supplement the wind in calm conditions. There was no protection from the weather. Sailors slept under their oars, wrapped in wool and sealskin, exposed to rain and spray and cold in a way that would be unimaginable to modern ocean sailors, even on small boats with all their equipment. The North Atlantic in autumn is a hostile environment by any standard. In an open boat, it is something beyond hostile. It is the kind of environment that kills people, regularly and without ceremony. And yet, the Norse sailed it. They sailed it because they had to, because the fjords of Norway could only support so many people, because the arable land of Scandinavia was increasingly carved up among established families, and new generations needed new land, because the Norse cultural ethos valorized the sea in a way that made ocean-going not just economically necessary, but socially desirable. To be a good sailor was to be, in the most fundamental Norse sense, a good man. The sea was where you proved yourself. The sea was where you became real. The Norse settlement of Iceland was followed, within 2 or 3 generations, by the discovery of an even more remote and even less hospitable landmass. In the 980s CE, a Norseman named Eirik Thorvaldsson, Eirik the Red, so called for the colour of his hair and perhaps his temper, was exiled from Iceland for 3 years, following a series of killings that the Icelandic legal system found criminal, even by the relatively relaxed standards of 10th century Norse justice. Rather than wait out his exile in Iceland proper, Eirik chose to use the time productively. He had heard, from other Icelandic sailors, rumours of land further to the west, a coast seen at a distance perhaps, by ships blown off course. He sailed west, into waters that no Norse ship had intentionally entered before, and after approximately 1 week at sea, he found what he was looking for. He found Greenland. The naming of Greenland was an act of deliberate marketing, as Eirik himself acknowledged. He called it Greenland, he said, because men would be more willing to settle there if the land had a good name. The name was not entirely false. The southwestern coast of Greenland, in the medieval climate period, known as the medieval warm period, was genuinely more vegetated than it is today, with river valleys that could support cattle and sheep in limited numbers. But it was still Greenland. It was still a land of ice and permafrost and glaciers and polar bears and winter darkness. Eirik settled it anyway, established 2 colonies that would persist for several centuries, and became the patriarch of one of the most remarkable families in the history of exploration. His son, Leif Eiriksson, was born in Iceland, but grew up in Greenland, and in approximately the year 1000 CE, he sailed west from Greenland on a voyage that would become the first known crossing by a European of the Atlantic Ocean to the North American continent. He was not the first Norse sailor to see North America. That credit belongs, according to the Icelandic sagas, to a man named Bjarni Herjolfsson, who was blown off course on the way to Greenland around 985 CE and saw a forested coast to the west, but did not land. But Leif was the first to actually go ashore. He landed at a place he called Vinland, Wineland, or possibly Grapeland, referring to the wild grapes or berries his crew reportedly found growing there. The location of Vinland has been debated for as long as the sagas have been read, and the debate has been shaped by the archaeological discovery in 1960 of Norse remains at a site called Longs O Meadows at the northern tip of Newfoundland. The remains at Longs O Meadows, wooden buildings of characteristically Norse design, iron boat rivets, a spindle whorl indicating the presence of women. The artifacts of a small and temporary settlement are the only confirmed Norse presence in North America. Whether Longs O Meadows is Vinland itself, or a staging post for voyages further south to actual Vinland, is something historians continue to argue about with admirable energy and limited consensus. What is not in dispute is that Leif Eiriksson and a small community of Norse settlers who followed him in the years immediately after established a presence in North America roughly 500 years before Columbus. They did not stay. The sagas describe conflicts with the indigenous people they called Skraelings, a pejorative term whose exact meaning is debated. And it is clear that the Norse settlements in North America were eventually abandoned. The colony was too far from Greenland to be easily supplied, too isolated to defend, and too surrounded by a large and understandably hostile indigenous population to be sustainable with the numbers the Norse could spare. After perhaps a decade or 2 of attempts, the western settlement was given up, and North America retreated back behind its horizon, unknown to the European world, until Columbus. But the Norse voyages west had done something that could not be undone. They had established, for anyone with access to the Icelandic seas, that the Atlantic Ocean was not infinite, that there was land beyond it, that the edge of the world was not in fact at the western horizon. This knowledge, widely distributed in Scandinavia, known to some extent in the courts and ports of medieval Europe, did not immediately transform European geography or navigation. The Norse world was not the Mediterranean world, and the intellectual and commercial centers of medieval Europe were not particularly attentive to what the Icelanders knew. But the knowledge was there, seeded in the culture, waiting for the moment when someone with the resources and the motivation to act on it would come along. That moment was still several centuries away. And in the meantime, there was a different kind of ocean mystery demanding attention. Not the question of what lay beyond the western horizon, but the question of what lay beyond the southern horizon, beyond a particular headland on the coast of West Africa that had, for reasons that seem almost incomprehensible from the distance of the modern world, become the most feared piece of coastline in all of European maritime experience. The Cape is called Bojador. It sits on the western coast of what is now the Western Sahara, at approximately 26 degrees north latitude, about 1,000 miles south of Gibraltar, not particularly far by modern standards, not even particularly dramatic in its physical appearance. The headland itself is low and flat, extending a few miles into the Atlantic, with shallow shoals and persistent offshore winds, and a strong southward current that flows along this part of the African coast, with enough force to make sailing against it a serious challenge. By modern sailing standards, Cape Bojador is a nuisance. By the standards of early 15th century Portuguese navigators, it was the end of the world. The fear of Bojador was not entirely irrational. The shallow waters and offshore reefs presented genuine navigational hazards. The current and winds that made it easy to pass the Cape going south made the return journey, against both, genuinely difficult in the sailing ships of the period. There were no harbours of refuge for a considerable distance on either side, and perhaps most significantly, the Cape sat at approximately the boundary between the known and the unknown, the furthest point south that Portuguese ships had regularly visited, the edge of the cartographic world as far as the contemporary pilots were concerned. Beyond Bojador, the maps were blank, and a blank map, in the imagination of a medieval sailor, was not an invitation to exploration, but a warning of danger so severe that it could not even be specified. The folklore around Bojador was extraordinary. Portuguese sailors who had been in those waters, and many of them had been to the Cape but not beyond it, reported that past the headland, the sea turned green. Not the dark blue-green of the open Atlantic, but a pale, sulphurous green, the colour of sickness. The current beyond the Cape was said to run so fast that no ship could sail against it. The fog there was permanent. The sun, this close to the equator, would scorch any European sailor black. The magnetic compass would go wrong. Sea monsters waited in the shallows. The sea itself, at some point not far beyond the Cape, simply fell away into a void. The waterfall at the edge of the flat earth, the place where the ocean ended. None of these things were true. The sea did not change colour. The current was strong, but not impossible. The fog was intermittent. The sun was powerful, but not fatal. There were no monsters. There was no waterfall. But the belief in these dangers was real and powerful, and it had been reinforced by a generation of Portuguese sailors who had reached Bogador, looked south, and turned back. The turn was not always voluntary. In some cases, the pilots simply refused to go further. The fear was that complete, that unanimous. The man who ended this impasse, the man who sailed past Cape Bojador and returned to report that there was nothing there except more ocean and more coast, was a Portuguese knight named Gil Inês. He was not a particularly famous figure in his own time, and he is not particularly famous now. His name appears in the history of exploration, but always in the context of the larger story of the Portuguese Age of Discovery, as a necessary precursor to the greater figures who came after him. But what he did in 1434 was an act of genuine courage in the face of genuinely believed danger, and the story of how he came to do it illuminates something important about the psychology of ocean exploration. Gil Inês had attempted to pass Bojador before. In 1433, he sailed south, reached the Cape, turned back. He returned to Portugal and reported to his master, Prince Henry of Portugal, the figure known to history as Henry the Navigator, that the passage was impossible. Henry, who had been systematically commissioning voyages of exploration down the African coast for more than a decade, was not satisfied with this answer. He told Inês to go back, and this time not to turn back, to pass the Cape, to see what was there, and if he encountered difficulties with the current, the winds, the sea monsters, to deal with them. The argument Henry made, in the account preserved by the 15th century Portuguese chronicler Gomes Eanes de Zurara, was essentially this. The sailors who were afraid of Bojador were afraid of things they had never personally seen. They were afraid of stories. The stories might be wrong. Go and see. Eanes went. In 1434, he rounded Cape Bojador, standing well offshore to avoid the shoals, and found nothing. More ocean, more coast, more sky. The sea did not turn green. The current was manageable. The monsters did not appear. The world beyond the Cape was exactly the same as the world before it, in all its essential characteristics. And Inês came home and told Henry what he had found, and the psychological barrier that had stopped Portuguese navigation for a generation simply dissolved. Within a few years of Inês's passage, Portuguese ships were sailing hundreds of miles south of Bojador. The coast of West Africa, which had been the edge of the known world, became a known coast, and the edge moved further south, and then further south still, retreating always before the advancing ships, always promising more beyond itself, always surrendering its secrets to the sailors, willing to push past the stories and into the actual water. The systematic Portuguese exploration of the African coast continued for more than half a century after Inês's voyage, driven by Henry's successors and sustained by the commercial logic of what was being found: gold, ivory, slaves, and eventually a route to the spice markets of India that would make Portugal the wealthiest nation in Europe for a generation. In 1488, Bartolomeu Dias rounded the southernmost point of Africa in a storm so violent that he did not realize, for several days, that he had passed the Cape and was now in the Indian Ocean. He named it Cabo das Tormentas, the Cape of Storms. It was King João II of Portugal who renamed it the Cape of Good Hope, expressing the obvious commercial aspiration. Here, at last, was the passage to India. 10 years later, Vasco da Gama used Dias's discovery to complete the first European voyage from Portugal to India and back. The route around Africa was real. the Indian Ocean was reachable, and the commercial world that Arab navigators had built around the monsoon routes was about to encounter the particular kind of attention that European naval powers paid to things they found valuable. But the route around Africa, however revolutionary, was not the most audacious geographic idea circulating in the ports and courts of late 15th century Europe. There was another idea, pressed with increasing conviction by an Italian navigator living in Spain, that the world was round, which everyone who mattered already knew, and that by sailing west across the Atlantic, you could reach the Indies from the other direction. The idea was not original to Christopher Columbus. The geography was wrong, as the Portuguese court astronomers who evaluated the proposal in 1484 correctly calculated. But Columbus had something that the astronomers lacked: a patron willing to fund the attempt, a crew willing to sail, and an ocean that was, as it turned out, crossable. What the crossing revealed was not India, but an unknown world entirely, and the attempt to understand and circumnavigate that world led directly to the most extraordinary sea voyage in history, a voyage that would finally measure the true size of the ocean, and in doing so, force every human being who heard the story to revise their understanding of what the word immense actually meant. On the 28th day of November, in the year 1520, 3 ships sailed out of a narrow, winding channel at the southern tip of South America and into a body of water so calm, so blue, so utterly still after the storms of the passage that its commander named it, with a gratitude that borders on reverence, the Pacific Ocean. The commander was Ferdinand Magellan, a Portuguese navigator sailing under the Spanish flag, and the passage he had just navigated, a sinuous, treacherous, 200-mile corridor of fjords and narrow straits and violent squalls that cuts through the southern tip of South America, would bear his name forever afterward. What he did not know, what he could not possibly have known, was that the calm ocean ahead of him was approximately 10,000 miles wide. Magellan had set out from Sanlúcar de Barrameda in Spain in September 1519 with 5 ships and approximately 270 men. The objective was to reach the Spice Islands, the Moluccas, in what is now eastern Indonesia, by sailing west rather than east, proving Spain's claim to a western route and avoiding the Portuguese-controlled passage around Africa. The expedition had spent 14 months in the Atlantic and along the South American coast before finding the strait that would bear Magellan's name, and those 14 months had already consumed a significant portion of the provisions and, more importantly, the morale of the crews. The passage through the strait took 38 days. It was November, early summer in the southern hemisphere, which means the conditions were as good as they were likely to get. And still the passage was extraordinarily difficult. The channel winds and tidal currents made sailing complex and unpredictable. The landscape on both sides was bleak and magnificent. Bare rock and glaciers and dense subantarctic forest. No signs of any human habitation, except the distant fires of the indigenous people who lived on the southern shore, which Magellan called Tierra del Fuego, land of fire. One of the 5 ships mutinied and turned back for Spain during the passage. Another was wrecked in the channel. Only 3 ships emerged into the Pacific, and then they sailed, west and northwest, into the calm blue emptiness, and kept sailing. Day after day, week after week. The islands they had expected to find, vague reports suggested some sort of island group in the middle of the ocean, did not appear. The provisions ran out. The men began to eat the leather from the rigging, soaking it in the sea for days to soften it, then grilling it, then chewing it. They ate rats, paying half a ducat each for the animals caught by the more enterprising members of the crew. They developed scurvy, the devastating vitamin C deficiency that would kill sailors on long ocean voyages for another 2 centuries, until anyone bothered to investigate its cause and cure. Their gums swelled, their teeth loosened, their skin developed the dark blotches that were the visible symptoms of the disease, and some of them died of it, and their bodies were committed to the sea that seemed to have no end. The crossing of the Pacific took 98 days. They covered approximately 12,000 miles without a significant landfall, a distance so far beyond anything any European sailor had previously experienced that the fleet's pilot, Francisco Albo, could not reconcile his dead reckoning calculations with any existing map. The maps were wrong. The maps had always been wrong. The world was not the size anyone had thought it was. The Pacific Ocean alone was larger than everything shown on the best maps of the known world. Ferdinand Magellan did not complete the circumnavigation. He died in the Philippines in April 1521, killed in a battle at the island of Mactan, a battle he had entered voluntarily in support of a local king who had converted to Christianity, and which he might reasonably have avoided if his judgment had not been somewhat impaired by the exhaustion and privation of the preceding 18 months. He was struck by a poisoned arrow, and then, when he fell, surrounded and killed by the islanders, he had chosen to fight. He was approximately 41 years old. The circumnavigation was completed by his captain, Juan Sebastián Elcano, who brought the one surviving ship, the Victoria of the original 5, back to Spain in September 1522, with 18 surviving crew members from the original 270. They were, these 18 men, the first human beings in history to have sailed around the entire world. They had been gone for 3 years. When they arrived in Seville, they walked barefoot through the streets in a religious procession, carrying candles, in a gesture of thanksgiving for a survival that none of them had expected, and all of them had at various points given up on. The circumnavigation proved, beyond any possible doubt, that the Earth was a sphere. It proved that the oceans were connected, that the Atlantic, the Pacific, the Indian Ocean were not separate bodies of water, but different reaches of a single world ocean. It proved that the world was staggeringly larger than any map had shown. And it established, in the minds of the educated people of Europe, that the ocean was not an edge, but a beginning, that beyond any horizon you could reach was simply more ocean, and then more land, and then more ocean again, and that the whole thing was continuous, connected, and finite in the way that a sphere is finite, having a measurable circumference, even if it has no edge. What the circumnavigation could not settle, what remained for another 2 centuries, one of the most persistent ideas in European geographic thought, was the question of the southern continent. Somewhere below the horizon, below the latitudes that Magellan and Elcano had crossed in their terrified passage through the strait, there was, many scholars believed, a great landmass. Terra Australis Incognita, the unknown southern land. It had to be there. The logic of symmetry demanded it. If the northern hemisphere had its great continents, the southern hemisphere must have them too, to balance the weight of the world. The question was simply whether anyone would be brave enough or foolish enough to go looking for it. The Terra Australis Incognita was, in a sense, a geographic theory with a philosophical soul. It appeared on maps drawn by the ancient Greeks, who reasoned from first principles that a spherical Earth must have a balance of landmass in both hemispheres. It persisted through the medieval period in the work of Islamic and later European cartographers, who placed it on their maps as an enormous, hypothetical landmass filling the southern reaches of the globe. By the time of the great European voyages of the 16th century, it had acquired a specificity, a shape, a location, sometimes even place names, that gave it the appearance of established geographic fact rather than educated speculation. Magellan had passed south of South America and found the channel that bore his name. The land to the south of that channel was identified on the maps of the period as the northern coast of Terra Australis. Francis Drake, rounding the Cape in 1578, was blown south into truly open ocean and found nothing. The implication being that the southern continent, if it existed, was further south than previously thought. But it was still thought to exist. The man who would finally resolve the question was James Cook, a Yorkshire-born naval officer who had risen from the absolute bottom of the Royal Navy's social hierarchy. He had started his naval career as an able seaman, not an officer, to become the most accomplished navigator and cartographer of the 18th century, and arguably of any century. Cook's genius was not the genius of discovery in the old glamorous sense of being the first person to see some previously unknown place. His genius was the genius of precision, the ability to chart coastlines with unprecedented accuracy, to make systematic observations and record them systematically, to bring science to the sea in a way that transformed exploration from adventure into knowledge. His first voyage to the Pacific from 1768 to 1771 was primarily a scientific expedition to observe the transit of Venus from Tahiti, but it also accomplished the first accurate charting of the coast of New Zealand and the eastern coast of Australia. His second voyage, from 1772 to 1775, was explicitly designed to answer the question of Terra Australis once and for all. Cook sailed south into the Antarctic waters, deliberately seeking the southern continent, determined to find it, or to prove that it did not exist in the form that geographers had imagined. On January 17, 1773, Cook's ships, the Resolution and the Adventure, became the first vessels in recorded history to cross the Antarctic Circle. They were at 66 degrees south latitude, in waters of extraordinary cold and ice, and ahead of them lay the ice pack of the Antarctic, a continuous barrier of sea ice that extended, as far as any observation from the ship could determine, to the actual horizon and beyond. Cook turned north, went around the ice, turned south again, crossed the Antarctic Circle a second time in February 1773, and found more ice. He crossed it a third time in January 1775 and reached 71 degrees 10 minutes south latitude before the ice made further progress impossible. He never saw Antarctica itself. The continental ice sheet was hidden behind the sea ice that surrounded it. But he understood, from the ice he encountered and the icebergs he passed, that if there was land to the south, it was buried under ice and surrounded by conditions that made it essentially inaccessible. He wrote, in his journal, with the directness that characterized his scientific mind, he was satisfied that there was land in the south, but that it was buried under ice and would be of no benefit to anyone who found it His actual words were more measured, but no less clear. If a southern continent existed, he wrote, it lay under such conditions that the world would derive no benefit from it. The Terra Australis Incognita, in its imagined form. The habitable, resource-rich, populated southern continent that cartographers had been placing on maps for 2,000 years did not exist. What existed in the far south was ice, cold, and a continent that would not be directly sighted by any human being until 1820, and would not be set foot upon until 1895. Cook had not found the edge of the ocean. He had found, instead, the limits of what the Southern Ocean could yield to human beings in wooden ships, and he had established those limits with a precision that made everything that came before him seem, by comparison, like guesswork. Cook's legacy in the Pacific was immense. Over the course of 3 voyages, he charted the coastlines of Hawaii, New Zealand, Australia, the Pacific Northwest of North America, the Alaskan coast, and numerous Pacific island groups with an accuracy that previous European cartography had never approached. He was killed in Hawaii in February 1779 in a violent confrontation with islanders on the Kealakekua Bay beach, in circumstances that have been interpreted and reinterpreted by historians ever since. A death that, like so many deaths in the history of ocean exploration, occurred not in the open sea but at the coast, in the zone where ocean and land meet, and where the tensions between different ways of understanding the world come most sharply into focus. After Cook, the shape of the world's oceans was essentially known. The major coastlines were charted. The major currents were identified. The great geographic questions that had driven 5 centuries of European exploration. Where does Africa end? Where does the Pacific terminate? Does a southern continent exist? Had all been answered. But the ocean, it turned out, had one more dimension of mystery still unrevealed. Not the edge at the horizon, but the depth below the surface. An abyss that was, in its own way, as unknown and as strange as anything that the horizontal explorers had ever encountered. Before we descend into the ocean's depths, we should stay for a moment at the surface and acknowledge the full weight of what has been lost to it. Because the history of ocean exploration is not only the history of what was found, it is equally the history of what was taken. The ships that sailed out into the expanding world of known geography and never sailed back. The crews that vanished so completely that no trace of them was ever recovered. The logbooks and charts and specimens and observations that disappeared into the sea, along with the men who had gathered them. We began this story with La Perouse, and he is perhaps the most famous of the lost navigators of the Age of Discovery. But the ocean has claimed many others, and each disappearance carries its own particular weight of mystery, its own tangle of theories and investigations, and unanswered questions that have, in many cases, occupied the attention of historians and explorers for generations. The case of the HMS Erebus and HMS Terror is among the most extensively investigated disappearances in the history of exploration. The 2 ships, bomb vessels converted for polar service, their hulls strengthened against ice, sailed from Erebus Bay in the Thames estuary in May 1845 under the command of Sir John Franklin, a 60-year-old Arctic veteran who had already survived one catastrophic overland Arctic expedition and was, by the standards of his era, an experienced and capable polar navigator. Their mission was to navigate the Northwest Passage, the sea route through the Arctic archipelago north of Canada, that European navigators had been seeking for 300 years, ever since it became clear that the direct westward route to Asia was blocked by the North American continent. Franklin had 128 officers and men. He had 3 years' worth of provisions. He had the most modern equipment available. He was never seen by European eyes again. The search for Franklin began in 1848 and continued in various forms for more than a decade. More than 30 expeditions were mounted by the British Admiralty at an expense and effort that eventually exceeded, by some estimates, the cost of the expedition itself. What they found, gradually and incompletely, was a story of almost unbearable grimness. Both ships had been trapped in the ice north of King William Island in the winter of 1846 to 1847. Franklin himself died in June 1847, along with several officers and men. The survivors, more than 100 of them, had abandoned the ships in April 1848 and attempted to walk to safety across the Arctic tundra. They did not make it. Their bodies and fragments of their equipment were found scattered across a vast area of the Canadian Arctic. The last survivors appear to have perished from a combination of cold, starvation, scurvy, and, as forensic analysis of the bones has subsequently revealed, lead poisoning, likely from the badly soldered tin cans that formed a significant part of their provisions. The ships themselves, the Erebus and the Terror, were not found until the 21st century. The Erebus was located in 2014 by a Canadian Archaeological Survey team, lying in relatively shallow water off the south coast of King William Island, in a place that subsequent analysis of oral histories from the local Inuit community suggested the Inuit had known about for generations. The Terror was found in 2016, in even better preservation, sitting nearly upright on the seabed of Terror Bay. The ships, after 170 years, were intact enough that the crew's personal belongings, their plates, their buttons, their instruments, were still recognizable inside the hull. The discovery of the Franklin ships did not resolve all the mysteries of the expedition's fate. It deepened some of them. Why were the ships so well preserved? What happened in the final months before the last survivors gave up their march and died? The Inuit oral histories speak of a ship found by local people with a survivor still aboard, and a group of men too weak to walk who accepted food from the Inuit and then were not seen again. These accounts have never been conclusively connected to specific physical evidence. The ocean, even when it gives back the ships, keeps certain things. And then there is the case of Amelia Earhart, which belongs to a slightly different era and a slightly different ocean, but carries the same essential quality: the disappearance into blue emptiness, the search that finds nothing conclusive, the absence that refuses to be explained. Earhart vanished over the Central Pacific on July 2nd, 1937, attempting to fly around the world along an equatorial route with her navigator, Fred Noonan. She was attempting to find Howland Island, a tiny coral atoll, not quite 3 square miles in area, sitting in approximately 4,000 miles of empty Pacific. She could not find it. Radio communications with the Coast Guard cutter Itasca, stationed at Howland to guide her in, became confused and then stopped. The aircraft disappeared. No confirmed wreckage was ever found. The mystery of Earhart's disappearance has generated an industry of speculation and investigation that shows no signs of exhausting itself. The theories are numerous and mutually contradictory. She crashed at sea and sank. She landed on the reef at Nikumaroro Island, a few hundred miles off course, and survived there for some period. She was captured by the Japanese and died in captivity. None of these theories has been definitively proved, and none has been definitively disproved. The Pacific absorbed her aircraft and her navigator, and whatever she had understood about the sky and the sea. Oh, and it did not give them back. These disappearances, La Perouse, Franklin, Earhart, and dozens of others less famous but no less complete, speak to something fundamental about the ocean's relationship with human ambition. The ocean does not reward ambition uniformly. It rewards preparation and skill and judgment to a degree. But it also has a capacity for indifference, a vast geological indifference to whether the particular vessel crossing it is commanded by the most brilliant navigator who ever lived, or by the most foolhardy and unprepared. The storms do not make this distinction. The ice does not make this distinction. The Pacific does not make this distinction. The ocean that swallowed La Perouse's frigates swallowed them without any apparent awareness of who was on board or what they had accomplished. The ocean takes what it takes, and what it takes, it often keeps. The deep ocean, which covers more than 70% of the Earth's surface and reaches depths of more than 7 miles in its deepest trench, has swallowed more human artifacts and human remains than any other environment on Earth. And for most of human history, the depths of that ocean were as completely unknown as the furthest horizon, as dark, as unknowable, as productive of fear and speculation. The first serious attempt to measure and understand those depths would not come until the second half of the 19th century, when science finally began to ask what lay beneath the surface of the ocean, in the cold and the dark and the immense pressure of the abyss. The deepest point on the surface of the Earth is not a mountaintop. It is a place in the western Pacific Ocean called the Challenger Deep, in the southern end of the Mariana Trench, at a latitude of approximately 11 degrees north and a longitude of 142 degrees east, where the Pacific Plate dips beneath the Mariana Plate in a geological subduction zone that has been deepening for millions of years. If you were to place Mount Everest at the bottom of the Challenger Deep, its summit would be more than a mile below the ocean's surface. The depth at the Challenger Deep is approximately 36,000 feet, nearly 7 miles of water, pressing down with a force of about 8 tons per square inch at the very bottom. In absolute darkness, at temperatures just above freezing, in an environment so hostile to life as we normally understand it, that the first scientists to consider it assumed it was essentially lifeless. They were wrong about the lifelessness, as the ocean consistently proves everything we assume about it to be wrong in interesting ways. But the assumption is understandable. The abyss seems like the negation of everything that life requires. Light, warmth, moderate pressure, access to the surface's chemistry. It seemed for a long time like the ocean's final secret, the one thing about it that could never be reached or measured or understood. The expedition that began to change this understanding departed from Portsmouth, England, in December 1872 aboard HMS Challenger, a Royal Navy corvette that had been stripped of most of its armament to make room for scientific equipment. Dredges, water sampling bottles, temperature gauges, and miles of sounding line. The Challenger expedition, funded by the British government and organised by the oceanographers Charles Wyville Thompson and John Murray, was the first purpose-built scientific oceanographic expedition in history. Its mission was simple in concept and staggering in execution: to measure the depth of the ocean, to sample the water at different depths, to dredge the bottom, and to record everything that was found. Over the next 3.5 years, the Challenger traveled nearly 70,000 nautical miles, taking soundings at hundreds of locations, dredging the bottom in deep water for the first time in history, and collecting biological samples from depths that no one had previously believed could support life. What the expedition found in those samples was astounding. The deep ocean was not a lifeless abyss, but a habitat, sparse and strange by surface standards, but genuinely inhabited, with creatures of extraordinary variety: brittle stars and sea cucumbers, and strange crustaceans and worms and mollusks adapted to conditions of pressure and darkness that no surface animal could survive. The deepest sounding taken by the Challenger was made in May 1875 in the Western Pacific, and it recorded a depth of approximately 26,850 feet. This was the first measurement of what would eventually be identified as the Mariana Trench, the deepest part of the ocean. The sounding line, lowered over the side of the ship, took hours to reach the bottom, and the crew had to splice several coils of rope together to have enough length. The whole process, lowering the line, waiting, raising it back, took the better part of a day for a single measurement. The Challenger took 247 such measurements during the expedition, each one a small act of mechanical heroism. The reports generated by the Challenger expedition filled 50 substantial volumes and occupied the attention of scientists for decades. John Murray, one of the expedition's scientists and eventually the editor of its official reports, calculated from the data that the average depth of the world's oceans was approximately 12,500 feet, more than 2 miles. He estimated the total volume of the world ocean at approximately 333 million cubic miles. These figures, arrived at by 3.5 years of patient measurement with a weighted line and miles of rope, have been refined by subsequent technology, but not fundamentally overturned. The Challenger gave the ocean a shape, a scale, a dimension. It made the abyss, if not knowable, at least measurable. The Challenger's measurements could not put a human being in the deep ocean. For that, a different kind of technology was required, and it came in the form of the bathysphere, a hollow steel sphere, 4.5 feet in internal diameter, connected to a ship on the surface by a single steel cable and a telephone line, with porthole windows of thick quartz glass, through which an occupant could, theoretically, see what was outside. The first bathysphere was designed by the engineer Otis Barton and first used in 1930 by the naturalist William Beebe, who descended to 1,426 feet in the waters off Bermuda and became the first human being to observe deep-sea creatures in their actual habitat, rather than in a dredge net on the deck of a ship. Beebe's accounts of what he saw through the quartz windows of the bathysphere are among the most remarkable nature writing of the 20th century. He described creatures that glowed with bioluminescence, their own cold, blue-green light, in the absolute darkness of the deep. He described fish with disproportionately enormous mouths and teeth, built to catch whatever organic material fell to them from above. He described, above all, the quality of the darkness itself, not the ordinary darkness of a closed room or a night without stars, but an active darkness, a darkness that pressed against the windows of the sphere with a physical quality, a darkness that seemed to have texture and substance. He was in a foreign country, a place that no language had words for, and he found words anyway, because the experience demanded them. The ultimate descent into the Challenger Deep came on January the 23rd, 1960, when the Swiss-designed United States Navy-operated Bathyscaphe Trieste, piloted by Jacques Piccard and Don Walsh, descended to a depth of 35,800 feet, within a few hundred feet of the very bottom of the Mariana Trench. The descent took 4 hours and 48 minutes. At the bottom, Piccard and Walsh had approximately 20 minutes of observation time before beginning the 3-hour ascent. What they saw, in the pale beam of their light, at the bottom of the deepest ocean, a flatfish, resembling a sole, moving slowly across the sediment, and a shrimp, life, at the deepest point on Earth, in the cold and the dark, and the crushing pressure, going about its business. The ocean, it turned out, had no edge, not only horizontally, but vertically. It went all the way down, and all the way down, things were alive. We are left, at the end of all this navigating, after the Phoenicians and Pytheas, after Ibn Majid and the Polynesian star readers, after Eric the Red and Gil Eames and Magellan and Cook, after the bathysphere and the Trieste. We are left with the same ocean that humanity has always faced, vast, indifferent, full of life and full of death, generous to those who learn to read it, and equally capable of swallowing without trace the best and most carefully prepared ships that have ever been built. The edge of the ocean was never there. This is the thing that every generation of ocean explorers eventually discovered, each in their own way, each carrying the particular cultural freight of their own era's fears and assumptions. The Phoenicians sailed around Africa and found more ocean on the other side. Pytheas sailed north until the ocean turned solid and came back to report that the solid was ice, not the rim of the world. The Norse sailed west until they found land, and the land turned out to be a continent, and the continent was not the end of things, but the beginning of a new set of things. Cook circled Antarctica and found no warm southern paradise, only ice and cold and the edge of what is survivable in a wooden ship. The deep-sea explorers descended to the bottom and found flatfish going about their business in the dark. The horizon is, of course, a kind of edge. It is the edge of what you can see from where you are standing. Every ship that has ever crossed the ocean has sailed toward a horizon that retreated as they advanced, that never arrived. There was always exactly the same distance ahead, regardless of how far they went. The horizon is a perfect metaphor for the edge of the ocean, because it has the essential quality of that edge. It is real enough to orient yourself by, but you can never reach it. You can only keep sailing toward it, and in sailing toward it, find what is actually there. What is actually there, as it turns out, is more ocean, and more coast, and more people who have already been living on that coast for thousands of years, who have their own stories about where the ocean ends, and their own names for the stars that help them navigate, and their own traditions of courage and foolhardiness and loss at sea. The history of ocean exploration, seen from a certain angle, is the history of different civilizations repeatedly discovering each other, sometimes with wonder, sometimes with violence, sometimes with both simultaneously. As they each push out from their own coast and across the water, and find that the water is not empty, that the horizon conceals not a void, but another shore. The sailors who searched for the edge of the ocean were searching for something that does not exist as they imagined it. And yet, their search was not wasted. Every voyage that went looking for the edge and found instead something new, a new coast, a new wind pattern, a new depth, a new creature glowing in the dark, added something to the sum of human knowledge about the world. The maps that came out of these voyages were imperfect, frequently wrong, sometimes deliberately falsified to mislead commercial competitors, occasionally so right that they were not improved upon for centuries. But they accumulated. They corrected each other. They built, slowly and imperfectly, and at the cost of thousands of lives, toward the comprehensive picture of the ocean that we now possess. And that comprehensive picture is itself not complete. The ocean remains in important ways less well mapped than the surface of Mars. The deep ocean floor has been surveyed in detail for less than 20% of its extent. The species inventory of the deep sea is, by most estimates, still far from finished. New species are found on every deep sea expedition, creatures that no human eye has ever seen before, living out their lives in the cold and the dark at the bottom of a trench or canyon that no instrument has previously visited. The chemistry of the deep ocean, its role in regulating the Earth's climate, its relationship to the geological processes happening at the ocean floor. These are areas of active research, not settled knowledge. The ocean is still being explored. The edge is still retreating. And somewhere in the ports and harbours of the maritime world, there are men and women pointing their instruments and their intentions toward the parts of the ocean that are still, in one sense or another, blank on the map. Going down, going out, going deep, asking the same question that every sailor who has ever launched a vessel into open water has implicitly asked. What is there? There is more ocean. There is always more ocean. And in the more ocean, there is more of everything. More life, more depth, more weather, more mystery, more of the particular silence that fills the space where human understanding has not yet reached. The sailors who searched for the edge of the ocean found instead the character of the ocean itself. An ocean without edges. An ocean that connects everything to everything. An ocean that began on the first day of the Earth's existence and will outlast everything we have built upon its shores. The Boussole and the Astrolabe sailed into that ocean in 1788 and did not come back. What they found on the reef at Vanikoro, in whatever last hours the ships had before the sea took them, we can only imagine from the fragments that washed ashore. A bronze cannon, an anchor, pieces of timber worn smooth by 2.5 centuries of Pacific current. The ocean kept the rest. The ocean keeps what it keeps. But the stories go on. They have always gone on. They will go on long after the last person who heard this one has fallen asleep, dreaming perhaps of a ship on a dark water, moving toward a horizon that is always just ahead, always luminous, always promising that the next distance will reveal the thing that every sailor since the first one has wanted to know. There is no edge. There is only the next horizon. And beyond it, the sea.